All right, thank you. Thank you, everyone, and thank you, Megan, for that very nice introduction. So I have a lot to deliver on with the promise that I said I would share with you the biggest technology development of our lifetime. And so let's get started here. Sorry about this. Yeah, so first of all, congratulations to Shibaura Machine for a 50-year anniversary. It really is an amazing accomplishment. For me, as a technology entrepreneur, I feel great pride and privilege to be here. I personally really love machines. I've always been fascinated with machines, and that's why I've dedicated my life to being a machine controls engineer. And when I look at Shibaura Machines, I see precision, I see quality, I see innovation, all the things that has made Shibaura into the great company that it is. And for me at ei3 Corporation, we're very proud to be a part of the partner ecosystem that services Shibaura. But all of those things, quality, precision, innovation, is small compared to, I think, what's the real value of Shibaura Machines, and that is its people. I want to say a very big thank you to Hank Azuma for the vision of MachiNet Cloud and the trust that he's invested in ei3 to have us be the partner. I also want to give a big thank you to Hemantha Wansekara. He was sitting there, but I don't know where he is now. Hemantha, oh, there he is, Hemantha. And Hemantha has been a great person to work with as he is now the head of the Shibaura Digital Services, the general manager of digital services at Shibaura, and also a great friend. I think Shibaura is very wise by putting so much attention on these digital services. And they're wise because the impact of the digitalization of equipment is something that we're in the middle of a big transition, and so we don't necessarily feel it as much. But historians will look back at this time and they'll marvel at how much change we were able to absorb in the way that we produce things during this early part of the 21st century. So for my presentation, what I want to do is talk about embracing the future. I want to look a little bit at the past, how machines have been controlled over these 50 years, and then share with you my perception of what the future might hold. By no means is it guaranteed because predictions are especially hard to make about the future. But that being said, we can certainly see some trends that will lay out kind of like a path for us, that if we pay attention to that path, we would all be in a position to take early advantage of key developments and key technologies in ways that will benefit our business. I know all of us here in one way or another are a contributor to a business, and so knowing what to do next, knowing what the future will hold, will give us that insight that we need to make all of the right decisions. So with that as the start of the journey, let's look at the past. And I really enjoyed Chris's slides, and I almost put up a slide of Richard Nixon too, but I didn't. So he did it for me. I appreciated that. But remember back in 1974, I wasn't. I was in high school. I wasn't out working, but I was certainly old enough to know what a machine looked like. And I remember those machines of the 70s. They had manual controls, pneumatics, hydraulics, timers and relays, and operating machines was very much a skill that required a lot of manual intervention. The way that the machine would interact with the person making the parts was very much a function of that person. Then in the 1980s, something really important happened. It was so important, a lot of people called it the third industrial revolution. The first industrial revolution, everybody knows, right, was the invention of the steam engine. That's when you could really start moving things around because you had powerful steam engines. The second industrial revolution was the advent of the electric motor and assembly lines. Well, the third industrial revolution was the addition of the microchip and having things like programmable logic controllers. Programmable logic controllers were digital devices that could actually control the action and reaction of machines. So an operator would no longer be called upon to make all of the decisions. Now you had automation making the decisions, and machines started to get a lot more repeatable because it didn't have that human input required to make the parts. The machines would make the parts themselves. Of course, that started to get more and more advanced, and at Shibaura you had the V10, the V15, the V25, and all of these different controls, which were then adding computers to the control of the machine, and took that digital control from just pure logic and brought it to a higher level where you could do things like set recipes, have automated limits that a machine could not go above or below certain thresholds or else you would get alerts. That greatly improved the repeatability and the quality of the produced materials that the machines could make. And Shibaura was right there. They had the TOS cast system for casting lines. They had the TOS NUC system for numerical controlled machines. And of course, the IMMs had their V series of IMM control. So going further now, getting to the 2000s, and stay with me, I'm just going to make a point here. It's coming. In the 2000s, all of those controllers then started to have digital communications. So it was not just a machine standing by itself, but the machine could tell beyond just the operator of the machine, it could tell other machines what it was doing. And so then people who owned factories started connecting machines together in production lines or work cells where they could interface all of the actions and reactions of machines. And of course, those communications, they got more and more advanced to where they are now, where they were based on Ethernet. And once it started to get to Ethernet, then the fourth industrial revolution was teed up. And that was, if machines are talking to other machines on Ethernet, they could also talk on the internet. And they could send the data beyond the walls of the factory. They could send the data actually to some centralized place. Today we call it the cloud. Of course, back in 1999, starting ei3, it was just a data center. But the Internet of Things was sparked by this communications that came from the digital machine controls that was routable over the internet. So you had secure digital communications, pervasive computing, and the low-cost sensors all came together that you could remotely have a complete picture of what a machine was doing. That complete picture, some people call it a digital twin, right? You know so much about what the machine is doing, you don't even need to see the machine anymore. You know all of its actions and its reactions. And by doing that, the machines could have an unprecedented capability. You could start to do things that you could not only dream about when you were having just isolated machines in a factory. Let me give you an example. I think I heard it mentioned 4 or 5 times here today, the word sustainability. Sustainability I think it was the top word used at the NPE show. Everything had a sustainability this, sustainability that. And there's a very real reason for it. Sustainability is important. Sustainability is important to our planet. So we as humans have a responsibility to leave less of an impact than we make so that we can have the planet here for our future generations. And we're realizing that we're actually using more resources than are sustainable, so we need to change that. Consumers are actually changing the consumer behavior towards brands that are sustainable. So I heard somebody was making car parts, and they were saying, the car OEMs have sustainability guidelines around the parts that they're delivering, and that's very true. One of our customers that we work very closely with is Hilton Hotels. We deliver their sustainability software, and we help them reduce their carbon footprint by more than $250 million a year of energy consumption. Hilton does this because people are deciding what hotel they're going to stay in based on the sustainability, on the environmental impact. P&G, a big customer of plastic-made pumps like soap bottle pumps and so on. They know that customers are choosing the consumer CPG, consumer purchase goods, based on the sustainability. So because these big brands are looking at sustainability as a lens for making their supply chain buying decisions, us manufacturers have to have sustainability data that we can provide. And in fact, it's even worse than that. These supply chain decisions are so important. They have to be auditable and trackable, because the SEC, the Securities Exchange Commission, put forth a law that was put into effect last May that said if you're going to publish an ESG report, if you're a publicly traded company with an ESG report, you have to have auditable, trackable, traceable sustainability data. You can't just greenwash. You just can't make it up. So that comes to the shop floor, and now the shop floor is saying, all right, how much was the carbon footprint of this phone case, right? It's a very reasonable question. If I'm Samsung and I'm buying, several hundred million of these phone cases, I want to know what's the environmental impact. Well, that's a difficult number to come up with, because you need to know when the machine is running, you need to know how much electricity it's using, how much pneumatic air is flowing to it, does it have cooling water, all of these things. And so it becomes a very real challenge. Engineers then are called upon to make estimates, go to Excel, roll up numbers, get utility bills. All of this takes time, and I think everybody in this room knows that time is money. So it's a costly project to try and get the sustainability data. So sustainability, or sustain, is an ideal application of the Internet of Things. What if you just hooked up your machine to the Machinette cloud, and all of its energy use, all of its water consumption, all of its pneumatic air, and its units of production are all known in a cloud? Then if you want to say on a job-by-job basis, what's the sustainability? You just hit a button and boom, there's your sustainability report. So that's an example of how the Internet of Things can track and do analytics in a way that's very difficult to do on a factory floor level. And you can take that to other key parts of the factory. We had fun with the panel with Michael Warner and the two Chads, right? And we were talking about different applications. Well, the Internet of Things can be used for tracking production, right? OEE numbers. The Internet of Things can track the downtime, and you can do a Pareto. What are the most common causes of downtime? Internet of Things can look at quality, track the recipe that made the quality. A big one, and one of my favorites, is tracking the life cycle of the parts, the tooling, and the maintenance actions of a machine, so you can make sure that your machine is running smoothly at peak performance and being as safe as possible. So all of these become different value propositions, and it's hard to say what is the one singular value proposition in the Internet of Things, because there's so many. But all of that is then brought to you by Shibaura machine as Machinette Cloud. You have access to all of these capabilities if you want them by contacting Shibaura and saying, I want to put Machinette Cloud on my equipment and I want to enjoy the benefits of the Internet of Things. But there's a really big benefit. This benefit is so big that sometimes I find it staggering when I start to think about it. And that benefit is what's coming right around the corner. probably everybody in this room has had some interaction or other with AI, right? Whether it's, ChatGPT. I remember around Thanksgiving of almost 2 years ago when ChatGPT 3.5 came out, it was like, wow, this is amazing. This is going to change everything. When I first saw ChatGPT 3.5, it was like when I first saw the internet. It's like the whole world just changed. And of course, ChatGPT 3.5 is now joined by 4.0, and now there's others. There's Meta, there's Gemini, there's Claude, and these AIs are getting really good, and they're getting better and better by the month. And when you go to the AI, you can ask it almost any question. What would be the best way to organize the tables of a conference room, and it will give you some ideas about different ways to do it. And it does that because it read the internet, and it has compiled a kind of a knowledge from reading the internet that it can answer questions that you would ask it in plain language. So imagine if you're in charge of a factory, if you're in charge of a work cell or a group of machines or any kind of a business plan, and imagine if you had an AI that had access to just your data, private and confidential to you, not shared with anybody else, your data, but all of your data, how your machines ran, what was the production, what were the quality problems, who ran the machine, what job was the machine on, what was the weather outside, how recently was it maintained, all of that data in one place. And then it was analyzed by an AI of the same capability as a ChatGPT. You could then ask it questions, say, I've got a 100-ton job that I need, but I have this important customer. What should I do? And it would say, wait till that job is done, then put it on machine 3, and you're going to get, the most optimal results. This technology is being worked on today. It's not far into the future. There's already, I can tell you from the software development side of our business, there's already AI systems that will look at just your own software that you wrote, completely firewalled from the rest of the internet, and will help you write more web pages for your apps based on your own programming standards. We're going to have this for your operations very, very soon. So this actually, to my mind, is the biggest opportunity for manufacturing, again, of our lifetime, to put AI to work to help us optimize our operations. And to do that, AI has one and only one and very, very important requirement, and that is AI needs data. For the AI to work, the AI needs data. So if you're operating a factory and you think there's even a chance that AI is going to be there to give you the guidance and advice of the level of a ChatGPT, you should be gathering each and every bit of data that you can. You should become obsessed with data. I've heard people saying I'm a data nerd or whatever. You should become data obsessed. Take it to the next level, because that data, in 2 years, when it's commercially viable for AI to analyze your data, you're going to wish you had it, and there's no way you're going to be able to go back in time and create that data. You're going to wish you had that data. And with the immense vision and foresight that Shibaura Machine has, they've given you in the market an absolutely perfect way to get all of the data you need about your machine operations in the form of MachiNet Cloud. So as you think about your planning of your business and what you want to do, and I know that there's a lot of different solutions out there and lots of, many ways to get to the end goal. But if you're looking to get to the end goal, keep in mind that a good partnership between a globally respected precision machine building company like Shibaura and ei3 Corporation can give you the foundation of data that you need to plan for the future and take full advantage. So that's my food for thought for you here today. I really, again, appreciate the opportunity to stand up here and share these ideas with you. And thank you very much for your kind attention. And if you have questions, I'll be standing over there by the ei3 screen. So thank you very much, and have a good rest of your day.